Welcome to your Nexus 2 Help Guide. In this video, we will go over the new features added into Nexus 2.9. In Nexus 2.9, there are several additional features. Conventional Gate Model 2, or CGM2, is now native to Nexus. Improvements have been made to data management to visualize data quality. Quick Reports now displays normalized graph overlays. Users can view a mirror video camera image. The hybrid cast visual 3D model labeling template has been added to Nexus. I will also touch on several other additional features added to Nexus 2.9. Conventional Gate Model 2 builds on the foundation of the conventional gate model. The goal is to improve the outputs whilst maintaining backwards compatibility. CGM2 was developed by Dr. Fabien Leboeuf at the University of Salford. Within Nexus 2, CGM2 is now integrated natively, so that it is automatically installed with Nexus 2.9. For further information on the integration of CGM2, please refer to the following video, Conventional Gate Model 2 Native in Nexus 2.9. You can now quickly obtain feedback on the data quality of your data captures within the Data Management tab without needing to open each trial to access the information within the Quality tab. On the default Data Management tab, a new Quality column displays data quality information for each trial. From left to right, the information displayed for each trial includes the number of unused markers, the number of gaps for this trial, as well as the percentage of markers in this trial that are labeled. Users can overlay normalized trial data within Quick Reports. This allows users to quickly observe model outputs and intra-trial repeatability without having to use Polygon. When you go to Trials, Display Mode, and select Overlaid, the graph will either display one context, left or right, or in this case, both left and right for all cycles. If you select multiple trials, you will see all gate cycles for each trial displayed within the graphs. Users can now mirror the view displayed for both optical and video cameras. To utilize this option, please go to a camera view, select the View menu, and tick on Mirrored. Within this camera view, next to the title, you'll see Mirror appended. If a user would like to use the hybrid cast visual 3D model within Nexus, you no longer need to generate your own labeling template, otherwise known as a VST. The hybrid cast visual 3D VST is now included within Nexus 2.9. So the marker set is automatically labeled when using the auto-initialize labeling pipeline. I'll now touch on a couple of additional Nexus 2.9 features. We will look at the video camera foot strike counter, a couple additions to view options, the toast pop-up control, additional pipeline operations as well as modifications and additions to their properties, added Matlab and Python SDK operations, as well as the improved calibration volume reproducibility. Within the video camera view, you can now add a foot strike counter. This will enable the user to get quick feedback on foot contact when watching a video camera view. To enable this option, go to Window, Options, Foot Strikes, and tick on Show in Video Cameras. This functionality is the same as seen in the 3D perspective view. Two options have been added to the event identification mode. To view the first option, go to Window, Options, select Timebar, and go over to the Properties pane on the right. Next, scroll down till you see the event identification mode options. Here, you'll notice that the Zoom to Event is unticked by default. When ticked on, and an event is selected within the time bar in the identification mode, Nexus will zoom in 20 frames on either side of the event automatically for you. You do have the option to change this value as you see fit. The second option is found under Window, Options, Event Identification View Options, and then within the Properties pane on the right. To make it easier for an event to be identified more precisely, Nexus now provides an option for Event Identification Mode, which enables you to quickly load a specific view type. For example, you may find it helpful to quickly view a graph of a particular marker. In the Properties pane, you can change the view type from off to on, and then select a specific view type that you would like Nexus to change to when you enter the event identification mode. This new feature enables you to adjust the length of time that pop-up notifications are displayed and the maximum number of notifications which are displayed. To control the notifications, go to Window, Error Message Settings. Once here, you'll see options for the pop-up timeout, as well as the number of error messages that you want to be displayed at any one time. A new pipeline operation enables you to run a residual analysis to determine the optimum cutoff frequencies to apply for your low-pass filter for your devices. You'll find this pipeline in the Tools pane, Pipeline button, Fill Gaps and Filter Data section, called Residual Analysis Butterworth. The results of the analysis for each channel are displayed within the log. These values are also saved within the history file. You can now decide which channel output to use to apply as the cutoff frequency for your filter analog data Butterworth pipeline operation. Within the pipeline operations, under the Systems section, you'll find a pipeline operation called Set Delay Compensation. The new Set Delay Compensation pipeline operation enables you to save time and effort by applying a delay compensation for your digital devices to multiple trials simultaneously, instead of having to open up each trial individually and manually apply this compensation value. Within the Events and Time Bar operations, you'll find Delete Time Bar Events. Within the properties of this operation, you can now clear all events from one context only. For example, you can clear all events from the left side, the right side, general side, or a custom context. Under the Systems section, you'll see a pipeline called Run Monitor. This allows you to run a monitor from the pipeline. You need to make sure to have a monitor created within the Communications pane Monitors tab. You can run this pipeline on multiple trials via the batch processing. Two new functions, getDeviceChannel for frame and getDeviceChannel for frame global, enable you to access digital device data that corresponds to your optical measurements. A new SDK command called getSubjectInfo allows you to identify which subjects are active for your current active trial. These new commands are available in the Nexus SDK for both Python and Matlab. Within the Tools pane, System Preparation button, and the Advanced Options for Set Volume Origin, you'll now see an option to auto-scale. To achieve maximum positional reproducibility of the Vicon coordinate system, you can create a custom large L-frame object from markers permanently placed around the edge of the volume. You can then use this L-frame object for subsequent setting of the system origin. This provides a high degree of precision of the coordinate system across the camera calibration. To help with this, select the new auto-scale option when you set the origin. This improves the consistency of the volume size, further improving the positional reproducibility. Thank you for watching this video. If you have any questions about your hardware or software, please do not hesitate to contact us at support@vicon.com. Feel free to use any of the links below for further documentation and resources.